Hello students, welcome to Learner's Planet. So this is our fifth theory session for the structure of the atom. So this is a topic which we were discussing for quite a while. Now we have discussed about the model of atom, about the atomic number, the atom or the mass number. And we have also discussed about the electronic configuration. That is how the electrons are distributed in the different energy levels of an atom. Now in this session we are going to discuss about the valency. See, the valency of elements. What is it? Or what are the valence electrons? And how few atoms and why few atoms are forming bonds or forming the compounds and some are not. Let's start our theory session here, students. So students, there's a term called as valence electrons. These are also called as valency electrons. Now what are the valence electrons? The electrons present in the outermost shell of an atom are known as valence electrons. See, whatever is the number of electrons in the outermost shell. Say if I'm taking beryllium, the atomic number of beryllium is 4. The electronic configuration will be 2 and 2. So how many electrons are present in the outermost shell? It is 2. So what will be the number of valence electrons? It will be also equal to 2. Now students, there is another thing, that is valency. What is valency? The combining capacity of an element is called its valency. Combining capacity means the number of electrons an atom loses or gains or shares to form a compound. Or we can say, in order to complete its octet. Complete its octet means in order to acquire 8 electrons in the valence shell. So that is the combining capacity of the element. The outermost electrons, they take part in the formation of the product or in the formation of any compound. So these are called as the valence electrons and the combining capacity is called as its valency. See, here is an example of sodium. The atomic number of sodium is 11, which means that one atom of sodium has got how many electrons? 11 electrons in it. The electronic configuration of sodium will be 2, 8 and 1. So what are the number of valence electrons in sodium? It will be 1. What will be the combining capacity or the valency of sodium? It will be also equal to 1. Say the configuration is 2, 8 and 1. Now if it loses this one electron, it will attain the configuration 2 and 8. That is it is having the 8 electrons in its outermost shell now, because this has lost. Now this is having 8 electrons in its outermost orbit or the shell. It is having the maximum number of electrons a shell can accommodate. So it becomes stable by losing this one electron. So what is the combining capacity of the sodium? It's 1. So what will be the valency of sodium? It will be 1. Let's take another example. See, this is magnesium. The atomic number of magnesium is 12. So what will be the number of protons in magnesium? 12. Number of electrons in magnesium? 12. And what will be the electronic configuration? 2, 8 and 2. This is the K shell, the L shell and the M shell. So how many electrons are present in the outermost shell? That is the valence shell. It's 2. So what will be the valency of magnesium? It will be 2. Now this is relation between valency and valence electrons. See, the valency of an element is either equal to the number of valence electrons in its atom. Valence electrons means the number of electrons in the outermost shell of an atom, or equal to the number of electrons required to complete its octet, or do it in case of hydrogen. Say hydrogen, atomic number 1, atomic mass 1. This is the atomic number, this is the atomic mass. The number of protons in hydrogen is equal to 1. Therefore, the number of electrons in hydrogen will also be equal to 1. Say if I take its noble gas element, that is helium, it has got 2, the atomic number is 2 and the mass number is 4. In case of helium, the number of protons is equal to 2 and therefore the number of electrons will be also equal to 2. So hydrogen needs to complete its duet. That is the maximum number of electrons which hydrogen atom can accommodate in its outermost shell is 2. So that is what is written here, that the valency of an element is either equal to the number of valence electrons in its atom or equal to the number of electrons required to complete its octet or duet in case of hydrogen. See, what is the valency? Now let's see the valency of metals. What is it? Valency is what? It is the combining capacity. That is, it is the number of electrons which an atom loses or gains or shares to attain 8 electrons in its outermost shell, or to complete its octet, or to complete its duet in case of hydrogen. Now in case of valency of metals, say what is the valency of metals? It is the number of valence electrons in its atom. So valency of a metal is equal to the number of valence electrons present in its atom. Whereas the valency of a non-metal element is equal to 8 minus the number of valence electrons in its atom. Say it's 8 minus. Let's take a few examples. Say for example aluminium. Aluminium is a metal. Now the atomic number of aluminium is 13. So what will be the configuration? That is how the electrons will be distributed in different energy levels. 2, 8 and 3. So what will be the valency of aluminium? It will be 3. That is, the valency is equal to the number of electrons in the outermost shell. So that is the valency. In order to attain 8 electrons, or in order to attain the noble gas configuration, that is 8 electrons in its outermost shell, what aluminium atom can do? It can lose 3 electrons. Aluminium, it will lose 3 electrons, form Al3 plus ion plus of 3 electrons. Now why this plus ion? Why there is a positive sign? This is called as cation, you know. See, the ion formed by loss of an electron is called as cation. See here aluminium. Now how many electrons? What is the configuration? 2, 8 and 3. So how will it will have 8 electrons in its outermost shell? By losing these 3 electrons. So aluminium will lose these 3 electrons and will form Al3 plus ion plus of 3 electrons. Now why this 3 plus ion? I told you that an atom has got equal number of protons and electrons. That is why an atom is electrically neutral. Protons are positively charged species and electrons are negatively charged. Now in case of aluminium, what is the atomic number of aluminium? It's 13. That is, the number of protons is equal to 13 and number of electrons is also equal to 13. Now when it has lost 3 electrons, number of protons still remains 13, but the number of electrons have now become 10. This aluminium ion is having 3 positive charges more. So it has formed a cation. What is the point of losing these 3 electrons? In order to have 8 electrons in its outermost shell. The outer shell has become empty by loss of 3 electrons and the penultimate shell becomes the valence shell then. Likewise, if I am taking here say lithium, it's a very small atom. The atomic number of lithium is 3. The distribution of electrons will be 2 and 1. What will be the valency of lithium? 1. Now it will lose this and will have how many electrons? 2. So it forms Li plus ion by losing one electron. Let's take up one more example. Calcium. The atomic number of calcium is 20. It means the number of protons in calcium is equal to 20, and which is also equal to the number of electrons. So what will be the configuration of this? What will be the electronic configuration of calcium? It will be 2, 8, and in the next shell 8 and 2. Now here a question will arise in your mind. The question is that, see, calcium, the configuration is 2, 8, 8 and 2. That is K, L, M and N. Now what we discussed according to Bohr-Bury scheme was that every shell or every energy level should have 2n square electrons. Now as per this, M shell should have 18 electrons. But it's not the case. Here it is having 8 electrons. Why so? See students, in any case, say 2, 8, it can have maximum of 10 and not 18. This many electrons it has. So what happens that 8 has to be there. So the 8 electrons fill up the M shell and rest of them move to N shell. If 18 electrons are not available in the M shell, then there will be 8 electrons here and the rest will move up. Like potassium. The atomic number of potassium is 19. The configuration is K shell, it's 2, L shell, it's 8, M shell, it's again 8, and N shell, it's 1. So in a shell, there can be either 18 electrons or 8 electrons. So if 18 are not available, there will be 8. Again, if 32 electrons are not available, there will be 18. So it's not that it can have 9 electrons. Now in case of calcium, how it will have 8 electrons in its outermost shell? Say this is nucleus 1, 2, 3 and 4. This is the valence shell and this valence shell is having 2 electrons. Now it will lose these 2 electrons. Then which shell will become the valence shell or the outermost shell? This shell will become the valence shell then, or the outermost shell. So after losing 2 electrons, calcium, the configuration will become what? 2, 8 and 8. But now in this case, the number of protons, say after losing 2 electrons, the number of protons here is 20, but the number of electrons is 18. So this particular species will attain charge. There will be 2 positive charge. It will not be neutral. Likewise, potassium will also lose its 1 electron and have the maximum of 8 electrons in its outermost shell, 2, 8, 8. In the new species form, the number of protons is equal to 19, but the number of electrons is equal to 18. So what will be the charge on potassium? It will be positive. So students, this is how the cations are formed. By loss of electron. Why the electrons are lost? In order to have maximum electrons in their outermost shell, that is 8. It is also said in order to complete its octet. So now these were the cases where electrons are lost. But in case of, see this is silicon atom. The atomic number of silicon is 14. Electronic configuration is 2, 8 and 4. Now in this case what happens? It is very difficult to lose 4 electrons or gain 4 electrons. So what silicon does is, it shares its 4 electrons. Let's take its example. Say in a compound SiH4. How it forms? Silicon. It has got how many electrons in the outermost shell? 4 electrons. So what it does? It shares these electrons with 1 electron of hydrogen. Hydrogen has got only 1 electron. Now what is happening? There is sharing. Now these electrons, these 2 electrons, that is the shared ones, these shared electrons, they are counted with hydrogen and also with silicon. Now let's count. With silicon, 1, 2, 3, 4, 5, 6, 7 and 8. So silicon is now having 8 electrons in its outermost shell or the valence shell. And what about hydrogen? Hydrogen has got 2 electrons. See, 1, 2, 1, 2, 1, 2 and 1, 2. So hydrogen is having 2 electrons in its valence shell now. So both have shared the electrons. So what is the valency of silicon? It's 4 and valency of hydrogen is 1. Hydrogen can have maximum of 2 electrons in its valence shell. Now let's take a few other elements. So there's another example here of phosphorus atom. See phosphorus, what is the atomic number? It is 15. Its electronic configuration 2, 8 and 5. Now in this case, it can't lose say 5 electrons. What it can do is it can share its 5 electrons. And now what is the valency? What is the combining capacity? It can't share its 5 electrons. If it's sharing its 5, it means it will be having 10 electrons in its outermost shell. So what will be the valency of phosphorus? 8 minus 5. That is 3. So valency of phosphorus is 3. It shares its 3 electrons and it attains the noble gas configuration. Likewise, the sulfur atom. What is the configuration of sulfur? It is 2, 8 and 6. And what will be the valency? 8 minus 6, that is 2. Likewise, we can take oxygen also. See oxygen. What is the atomic number of oxygen? It is 8. That is, the number of protons in oxygen will be equal to 8 and the number of electrons in oxygen will be also equal to 8. So what will be the configuration of oxygen? Electronic configuration of oxygen atom? It will be 2, 6 and 2. 2 and 6. I'm sorry, it's not 2, 6 and 2. It's 2 and 6. So the configuration is 2, 6. Now what will be the valency? Valency will be equal to 8 minus 6 and that is equal to 2. So oxygen, what it can do? It will accept 2 electrons, C1 and 2. In the inner shell, there are 2 electrons over here in the inner shell, with opposite spins I should say. And there are 1, 2, 3, 4, 5 and 6 electrons. So it takes up 2 electrons from another species, from another atom, from an electron donor. Say we can take here calcium. Now it can take 2 electrons from calcium so that its outermost orbit or the valence shell acquires 8 electrons. So what will be the configuration of oxygen then? It will be 2 and 8. Whereas calcium, the atomic number is 20, the electronic configuration is 2, 8 and 2. So it will lose its 2 electrons from calcium and calcium will acquire the configuration 2 and 8. It's 2, 8, 8, 2. So calcium has the configuration 2, 8, 8, 2. It loses its 2 electrons. Oxygen gains its 2 electrons. Right? And both have the configuration or both have 8 electrons in their valence shell. And they'll form a compound called as calcium oxide. CaO. It's not Ca2O, CaO. So it will form a compound that is calcium oxide. So what ion oxygen is forming? Oxygen is gaining 2 electrons. So it forms 2 minus. Why so it's minus? Say the number of protons in oxygen is 8. Whereas the number of electrons in this oxygen will be now 10. So it is having 2 extra electrons. So the ion formed is an anion. An ion. Likewise, it can share also, students. It can share 2 electrons. Say for example, see oxygen has got how many electrons? 1, 2, 3, 4, 5 and 6. There is another oxygen atom 1, 2, 3, 4, 5 and 6. Now what they do is they share their electrons and they form oxygen molecule. These shared electrons are counted with both the oxygen atoms. So if I start counting for this oxygen atom, it is 1, 2, 3, 4, 5, 6, 7 and 8. For this oxygen atom, it is 1, 2, 3, 4, 5, 6, 7 and 8. So both the oxygen atom acquire 8 electrons in the valence shell. So either it can share 2 electrons or it can gain 2 electrons to have or to acquire 8 electrons in the valence shell. So what is the valency of oxygen? It's 8 minus 6 and it comes out to be 2. The sulfur is also here. The valency is 2. So this is chlorine atom. The atomic number of chlorine is 17. The electronic configuration is 2, 8 and 7. So what will be the valency? The valency is 1. Now it has got 7 electrons in its outermost shell. So what it can do? It can accept 1 electron and attain the noble gas configuration or complete its octet, that is 288, and form the chloride ion. See how sodium chloride is formed. Sodium. The atomic number of sodium is 11. The electronic configuration is 2, 8 and 1. Whereas the atomic number of chlorine is 17. The electronic configuration is 2, 8 and 7. Now sodium, in order to complete its octet or in order to have 8 electrons in its valence shell or the outermost shell, what can it do? It can lose its 1 electron and chlorine will gain its electron. So sodium forms sodium ion. How it is forming? Sodium forms sodium ion. How? It gives out 1 electron and forms sodium ion. Chlorine forms chloride ion. By accepting 1 electron, it is forming Cl minus ion. What is the electronic configuration of sodium ion? It is 2, 8. What is the electronic configuration of chloride ion? It is 2, 8 and 8. And they form a compound. See, this is a positively charged entity and this is negatively charged. So there will be the force of attraction between them and it forms sodium chloride. So this is the way how elements react, how they form different types of compound. Now let's take an element which does not react and it does not form any compound. See here, this is argon. The atomic number of argon is 18. The electronic configuration is 2, 8 and 8. It has got 8 electrons in its outermost shell. So what is the maximum number of electrons an atom can have in its outermost shell is 8. The maximum number of electrons an atom can have in its outermost shell is equal to how much? Is 8. So argon is having 8 electrons in its outermost shell. So that is why it doesn't react with any other element and it is stable. It is also called as noble gas element or noble gas. It is inert. Likewise helium. Say helium has got 2 electrons in its outermost shell. So an atom can have either 8 electrons in its outermost shell. An exception is helium. It has 2 electrons and it's stable. So this is all about the valency of an atom. Now this valency is also can be further categorized as electrovalency and the covalency. Now we'll be discussing about them. There are 2 types of valency, the electrovalency and the covalency. So let's first discuss about the electrovalency. Electrovalency, the number of electrons lost or gained by one atom of an element to attain the nearest noble gas electronic configuration is known as electrovalency. See, in order to attain the nearest noble gas electronic configuration, that is maximum of 8 electrons in the outermost shell, or it's 2 in case of hydrogen. An atom loses or gains. So the number of electrons lost or gained by one atom of an element to attain nearest noble gas configuration is known as electrovalency. For example, sodium. We have discussed this already. Sodium, it loses one electron and attains the nearest noble gas configuration. Potassium. Potassium, the electronic configuration is 2, 8, 8 and 1. So it also loses one electron and attains the nearest noble gas configuration, that is 2, 8 and 8. So that is the electrovalency of potassium. The atomic number of lithium is 1 and its electrovalency is also 1. The atomic number of lithium is 3. The configuration of lithium will be 2 and 1. So what will be its electrovalency? 1. Likewise, see magnesium. It has got 2 electrons in its outermost shell. It loses its 2 electrons and attains the configuration 2 and 8. There is 8 electrons in the outermost shell. So what is the electrovalency of magnesium? It is 2. Likewise, calcium. The electronic configuration of calcium is 2, 8, 8 and 2. In order to attain the noble gas configuration, it becomes 2, 8 and 8. How? It loses its 2 electrons. Beryllium, the atomic number is 4. So the electronic configuration is 2 and 2. It also loses 2 electrons and attains the configuration, that is 2. Now here it is not completing the octet, right? So what is the covalency? It is electrovalency. It is losing 2 electrons. So the electrovalency is 2. So beryllium most of the time shares the electrons. Now the another term over here is covalency. So what was the electrovalency? Electrovalency is the number of electrons an atom is gaining or losing in order to attain the nearest noble gas electronic configuration is electrovalency. Then what is the covalency? It is the number of electrons shared by one atom of an element to attain the nearest inert gas configuration is its covalency. So the number of electrons an element is sharing, as in case of silicon I told you. It is sharing 4 electrons, that is its covalency is 4. Oxygen for forming we can take for attaining noble gas configuration is sharing 2 electrons. So its covalency is 2. See, oxygen shares 2 electrons. So it's what? Its covalency is equal to 2. Oxygen gains 2 electrons. So its electrovalency will be also equal to 2. Now let's take up this example of chlorine. A chlorine atom has 7 electrons in its outermost shell. So it can share its 1 electron with 1 electron or with 1 electron of another atom. 1 electron with 1 electron of another atom to complete its octet. Now chlorine shares 1 electron, so what will be its covalency? Its covalency will be, see, chlorine, the electronic configuration is 2, 8 and 7. So chlorine can be written as 1, 2, 3, 4, 5, 6 and 7. Likewise, there is another chlorine, 1, 2, 3, 4, 5, 6 and 1 electron is 7. So it will share its electron. Both the electrons it will share so that it is attaining the noble gas configuration. So the covalency of chlorine is 1 and electrovalency is also 1 because it will gain 1 electron and attain the noble gas configuration. So the covalency of chlorine is also 1. Covalency and electrovalency both are 1. What is the covalency of silicon? It's 4. Just we'll summarize now. What is the valence electrons? The number of electrons present in the outermost shell of an atom. What is the valency? It is the combining capacity of an element. That is, it is the number of electrons the atom of an element is gaining or losing or sharing in order to attain the nearest noble gas configuration. That is, in order to have 8 electrons in its outermost shell. That is what? That is the valency. Metals. In case of metals, valency is equal to the number of electrons in the valence shell. In case of non-metals, valency is equal to 8 minus the number of electrons in the valence shell. Now, valency is of two types, the electrovalency and the covalency. Electrovalency is what? It is the number of electrons an atom is losing or gaining. Covalency is the number of electrons an atom is sharing in order to attain the noble gas configuration. So I hope you have understood this, students, and also that why a particular atom is forming cation, that is the positive ion, and why another is forming a negative ion. I hope these things are clear to you. So now I'll be concluding this session, students. In the next session, which will be our last session, we'll be discussing about the isotopes and isobars. Now, students, it's your part to just go through the text and practice. Practice to write the electronic configuration. Just practice how you'll find out that whether a particular atom is forming a cation or an anion. Just go through your text. It will clear your concept. And thank you, students, for listening patiently, and do have a nice time ahead.